Alright, so welcome back to another video on Node.js, specifically on socket, and how this is one of an exciting feature in the fundamental of the internet. And to see an example of it, imagine that we are going to build a chat application with the theme that we already know so far, okay, which is the HTTP. So if we want to send a message, we send a post request, and it wants to read all the message or a single message, a GET request, right? So the thing here is that when do we know when to fetch data? And data that is outside of our control, data that we didn't create, that might be in their own life cycle. So for example, games or trading or self-driving car. So we often deal with this kind of situation quite effectively with an approach called polling, which it sends a GET request so often in a period of time, and when that time has passed, it will send a new GET request in a loop essentially. So with this approach, once I use the set interval JavaScript feature and define a rate pull rate of 500 milliseconds, this will add not only 500 milliseconds to all of updates, right, but also make one request or make two requests per second, 120%, 120 requests per minute per one single user. So here we have these two issues. One of them is that we're flooding our server with requests, as one of them, and the other is that when do we know, or when is the right time to make a request? Is there even a right period of time to do that? Doesn't the data depend how often it changes on the backend? So with these two issues, all right, that for example, for the real stuff like uh, trading, self-driving car, or games, that might not be feasible. For chat app, this might be okay. And this, for example, even though that we have these two different challenge, right? Socket comes to the rescue to help us here with this. And socket, after all, is an opening in a computer system. Indeed, a computer is just a programmable machine that performs logic and arithmetic operations. And system, a computer system, is this machine made of hardware, software. The main software is the OS, and it is peripheral. What you have is monitor, speaker, keywords, mouse, you name it. So this opening a computer system or a hollow that form a holder or that form a holder for something, and after all, that's the plain definition of socket. Okay, is a sorry. So that a socket is an opening. Sorry, Jesus. Okay, so that a socket is an opening or a hollow that form a holder for something, for example, electrical bulb sockets or the eye socket. So this computer system, which is an opening uh, in there, in which you can connect to send and receive message. So these data sockets are holder of this type of connections in a computer network, in a series of computers sharing resource located on or provided by network nodes. network knows that either they can be redistribution endpoints or redistribution points, such as the BGP router protocols, where BGP is a border gateway protocol that it exchange router data across different autonomous systems that is a series of interconnected networks operate under a single domain, such as Google, or under a single admin domain, such as Google, Facebook, Verizon, Cloudflare, right? So this network node can be either a redistribution endpoint or a communicational endpoint. So an address that allows to identify a communication entity, such as the, a communication entity, such as uh, an application, a server, desktop, router, switch, firewall. So an example of this network computers from real life applications, right? So we have is the citizens in a city, citizens in a country, all right? So that they exchange is info. So that they exchange is uh, knowledge, music, culture, fluids, insults, whatever you name. And now they are in the geographical locations that they belong to a particular country or to a particular single admin domain or a country, right? So this is an analogy that you can make. For example, when you talk about computer network and real life example like citizens like you and me in a country, right? So with that, all right, now that I know that this socket is what the internet is based on, millions and billions of sockets, right? So the basic building block of these sockets are the IP sockets, where on top of that you have, if you want low latency, you can use datagram socket for that. But if reliability or connection base are more important for you, TCP sockets is the way to go. Okay, so you know when you send a message and when that message has been received or not, and you need to connect before send or receive the data. And on top of the TCP connection, you have is the house duplex, all right, like HTTP or this two-way communication uh, from WebSocket, which is a JavaScript feature that any backend developer or web developer should be very familiar with. So now, looking at the WebSocket and the implementation of that, so much like the HTTP, have several implementations on how to fetch data, such as actions or no fetch. WebSockets now has an implementation like WS from Node, where this only works on the server, and if you want to make that happen, if you wanna make that work on the browser, you use this or the non-popular library that they recommend or WebSocket. The only trade-off with this approach is that now we have WebSockets on the browser and the WebSocket objects, the WebSocket API on the browser, and the WS library from Node. So their interface are different, all right, and they're quite verbose. If you want to make the most common operations on uh, this two-way communication data binding, okay, or this two communication operation. If you want to make a most common two-way operations, uh, is very verbose. So that's why there is an implementation very sexy appealing and convenient that allow this real-time communication bi-directional and event-based driven that works in any platform, Socket.io. So here I look at what is Socket.io, how actually that works for the client and the server, and even though that the client and the server has different responsibility, we have a unified API interface. So we don't have to juggling around different APIs or different set of functionality. We can focus it on writing our code, and also now we can is have less bugs, even though we're still going to have bugs. But if we can minimize 10 to 20% of them, that will save a lot of time and brain power. So this is something that I also Socket.io allow us to do and offer to us. Is another important feature for any production application of for any production for any production. Mhm. And for any production or another perk which is important, okay? Another perk which is important when building large scale production applications is the fallback. So when we start a socket.io, and this is something important, there is one there is one perk. There is one perk which is important when building large-scale production applications, the fallbacks. So socket.io, when you start out on the client, okay, so you install the client socket.io, and then you begin your chat application, okay, it will attempt to make a WS connection, a WebSocket connection between the browser and the server. If your browser is one of those that belongs to the last 3% that doesn't support a WebSocket, then Socket.io will attempt to form a polling. And this way, you are guaranteed that your application will work in any device. And this is something important for any corporate environment. So looking at this deeper implementation, okay, on how can we do, for example, or what are the most common things that we do from the client and the server, even though that we have a unified API interface. Remember, the client and the server both have different responsibilities. So the clients, they only talk to the server, right? In this two-way, um, in this two communication way, okay? But the server now needs to keep track of every connected client, while also, exactly, so keep track of every connected client. So keep track any connected client. Mhm. Keep up the client up to date, send message individually or a group of people, a group of connected clients, or broadcast to all of the connected clients. Okay? And with this responsibility, okay, I saw how easy it is to, for example, write code that broadcasts message to all of the connected client in contrast with the WS and the WS node library, right, which is more verbose. So, with that huge introduction, then I look at how can we apply that knowledge by writing a multiplayer pong game. And if you're not familiar with this is one of the first video games released in 1972 by a company called Atari on a massive cabin, right? So I make a code review from the code they give it to me, and the TLDR is that this code, for example, in video game, there is something called the game loop that any game has, from basic games like Tetris or Pong to modern games like Fortnite and Minecraft. So this is uh, the TLDR from that. So now, then I look at how can we implement that, okay, in a way that we can make our server thing as possible uh, by only taking is the relevant uh, logic to the server and let the user handle all of the render logic and some other logic as well. And also to avoid that uh, any player cheat during the game. So I know how can I set up a socket.io server and a socket.io client. How can I connect to that? And then how can I listen to events on the server? How can I listen to events on the client? The reason why we use, for example, HTTP model on the server to create our socket.io is for versatility, okay? Because if it wants to, for example, use HTTPS or attach our code to an existing Express app, we can do that easily. Okay, so then now I look at how can we handling events on the server, and then on the client, okay? And now implementing is the game logic particularly is just to keep up the server update with logic relevant to the ball movement and the pattern from one player to another player. Okay, but the thing to know here, the TLDR for this multiplayer pong game is that every game has something called game loop. And from basic games like Tetris and Pong to modern games like Fortnite and Minecraft. Cool. Because then I look at the UML, the Unified Model Language, the Unified Model Language, okay, to see what are the responsibilities that our server will have and the client. So we're gonna take all the non-render logic and other kind of logic to the server to avoid that any user cheat, and we can sync the client. Yeah, we can keep the client up to date. So I saw how can I create a server using socket.io, a client. How can I listen to events on both ends? How can I handling events? And now it's more relevant to keep the client up to date, which is implementing the game logic with the paddle and then with the ball movement. So that's it. So that's it. Ah, come on. And here we are, right? Implementing game logic pattern. So both of this, or these two, these two sections is just to know, is just to see how to make the client, how, yeah, how to make, how to keep the client up to date. This is the two from broad perspective here. Okay, so implementing the pattern logic here, implementing the game logic pattern. This section and the next is just to know how to keep the client sync with our socket IO server. Exactly. So if I look at this, and if I run here, this, let me npm run star, npm star. There is no need to add run. Great. Now if I open here this, if I say here, that's right, that's good. In one browser. Okay. So we're going to open this on Google. And there we go. It seems that we already have client side. Okay. So let me is refresh here our server because we don't have any logic here that even though that we are reconnected, we are now taking. Okay, so waiting for a component, so player ready. So if I open a new tab here, and then I paste this here, so we can see that we are controlling it. The, from one browser is controlling the bottom, the other is controlling the top panel. Cool, cool. That's awesome. Mm-hmm.
Position is reflected on both clients. I am currently moving the client on the right, and it's being kept in sync with the client on the left. Same thing in reverse. But there's something weird happening with the ball position. We've gone slightly out of sync between both clients, and the game state has become completely different, which we can see reflected in the scores. Let's find out how to take that final step and keep the ball in sync in the next video. I'll see you then. Welcome back. We've implemented our game logic for paddle updates. The final step before we have a functioning multiplayer Pong game will be to synchronize the ball position as it moves across the screen. And the source of truth for the ball position is going to be the referee player. The referee player is the one who's going to calculate the ball position and make sure that both clients agree on that same ball position. We know that the set of data that keeps track of our ball position is the ball x and ball y variables, which keep track of the x and y coordinates of that ball. We're going to need to emit this set of data to our server whenever the ball position changes.
Here, we need to emit this uh, this type of data whenever whenever the mouse change whenever the mouse change.
And luckily, we have this handy ball move function already implemented. Right after we adjust the ball position, we're going to emit using our
Here we're going to emit
handy emit function, the ball move event, passing in an object which contains the ball x and the ball y. But the ball move function isn't the only place the ball position is updated. We also have this ball reset function, which is called whenever one of the players scores and the ball moves past the opponent's paddle. So in both cases, we're going to need to do the same emitting of the event and say socket emit ball move. There's something really important that we need to do now, though. Remember, the referee is the one who determines the ball position and updates the non-referee player whenever there's been movement so that the two clients always agree on the ball position. And luckily, we already have this isReferee variable, which we set in our start game listener here to keep track of whether the current player is the referee. So in our ball move function, as well as in our ball reset function, and in fact, even the ball boundaries function, which determines where the ball is bouncing and when to reset the ball. All of these functions are only going to run on the referee client. The non-referee doesn't need to do these calculations.
exactly.
It just accepts the ball position that it receives from the referee. How are we going to do this? How are we going to separate the logic of the referee client from the non-referee client? Luckily, it's not complicated. In our game loop over here, we're only going to call our ball move and ball boundaries functions if we are the referee. And what I'm going to do here is I'm going to group the ball move and the ball boundaries functions together and render the canvas after the updates have been made. Now only the referee will move the ball and keep track of where it's bouncing, and in the process of doing so, it will emit updates to the server. The important change now is that the non-referee client is not tracking anything that's being tracked in these two functions,
Any of this ball.
which means that the ball position is not being tracked or updated, which we want. But if we scroll through our ball boundaries function here, we can see that, okay, the ball x, the speed x, and likewise for the y, are all related to the ball position, which is fine. The same applies to ball direction and trajectory. But there's another piece of data here, which is the score, that's only updated when this function is executed. And if this function is never executed on the non-referee client, the score will never be updated. Which means that the referee needs to send the score to the server as well, so that the server can then rebroadcast that data to the non-referee client. So we're going to add our score array to our ball move event as the final piece of data that we emit in both the ball move and ball reset functions.
Exactly. So when I look here at the script, on the no, no, the ball move. Right. So here we're going to emit this event, right? So we're going to emit is the ball move with some data here, which is the ball x, ball y, and the score. That this function, so this element will be emitted when the ball moves and when the ball reset as well. And we're going to call now this only if the referee is the referee. That the ball boundaries here and the ball move will only be emit that event and keep the client up to date, and only the non-referee will just receive this data, the ball X, the ball C, the ball X, the ball D, and the scores, and render them.
Now all the data that's being calculated in the referee client over here and not on the non-referee client is being shared with the server when we emit our ball move event. We've successfully separated the referee and the non-referee client in our front-end JavaScript code over here. Now on the server, we'll need to listen for our ball move event, much like we did for the paddle event. So again, we'll do socket on ball move.
And on our server, so what we're going to do is listen to another event, which is socket that on the ball move. Okay, socket that on the ball move, and we're going to receive is this data from the socket. Okay, and we're just going to emit that event, but now is to the to all connected clients except the sender, because after all, whoever is sending that message, which is our referee, we're not going to send the data to them. We might send the data to them. In our case, we might send the data in our case, but since it's the referee that is calculating the ball movement and its boundaries, so we're going to just send that data from the server to keep the non-referee player up, updated with the ball movement, the ball boundaries, and the score.
Taking in some ball data, and with this ball data, we'll again rebroadcast like we did before, not to all of the clients, but to all of the clients except for the sender of the.
Mm-hmm. Something here, I didn't set that socket that IO, socket that on to the paddle move, and paddle the paddle data will here. I'm going to resend that data socket dot emit dot broadcast. I think it's this broadcast dot emit broadcast dot emit the paddle move and the paddle data. And much like here, we're going to send that message, or we're going to broadcast that message to all connected clients except the sender.
The paddle move event, or the ball move event in this case. This is the difference between the socket broadcast.emit function here and the io.emit function that we used when starting the game, which is an event that all of the clients need to know about. Okay, so we're going to do socket.broadcast.emit ball move and passing through our ball data back to the non-referee client. Our server is now passing all of the data that we receive from the referee to the other player, which means that on the client side, we'll need to listen for this data and update our game state accordingly.
Mm-hmm. And that's right. So we're on the client side. We need to listen for that data, socket that on here of the paddle move from paddle data. Okay, so paddle move, paddle data. And now they're using is this logic to to keep the paddle track and sync with all of them. Where here is changing is toggle 1 into 0, 1 into 0, and 0 into 1. So anytime we receive this data from the opponent paddle index, we are just subtract that data from the paddle index, and the paddle index or the paddle x in this case, that's right. The paddle x is the opponent paddle index, and the paddle data dot x position. Are we sending that data to there? The question is that we will never send that event.
So below our paddle move function here, our paddle move listener, we'll add an onEvent listener for our ball move event. And our ball data,
so we're adding here
in this case, contains the ball's x position, the ball's y position, and the scores of both players. So we'll use this object destructuring syntax here. We'll say ball x on this non-referee client, ball y, and the scores, these will all be set to the corresponding values in the ball data object. And we'll wrap this all as a single statement, so our
okay. So here we're going to keep the client sync. That's right. So ball x, ball g, and score.
is happy. All right, our paddle and ball data is now being synchronized between the two players. Let's give our game a test run. We'll start our server.
Before going there, I need to now add the logic for the paddle.
Welcome back. Okay. At the index for our opponent.
Not here.
Broadcast.emit and passing in the only sent it that we received event. And this is where we're going to need to, as the payload here, with a single property, which is going to be the x position of the paddle as it's moved. And that's going to equal the paddle x at the current player's paddle index.
That's right, and you see it. So once you move, or once the client moves, let me look here. So when the client moves the mouse, we're going to now emit this event, the paddle data with this data, which is the x position that comes from the paddle x, and the paddle index,
Exactly the variable that we just updated here. So we're sending the current player's paddle position as it's being moved to the server so that the server can then re-emit that position to the opponent's browser. So the two paddles are in sync. Now on the server side, we're going to add
and now
let's give our game a test run. We'll start our server. And in our browser testing setup here, we can see that the paddle position is being updated between both players, but also, check it out, the ball is in the same position on both clients. We can now play a multiplayer game of Pong over our Socket server together. keeping track of all the game state, including the score, on both clients. It would be better playing with a friend, but I could play this all day. Alright, I'll see you in the next one. We'll start our server, responding values in the ball data object. And we'll wrap this all as a single statement so our linter is happy. Which means that on the client, the socket broadcast. Okay, so we're going to do socket.broadcast.listen for this data and passing through our ball data back to the non-referee client.
Mhm. Okay, the server crashed because we didn't. The server crashed because exactly. But now the paddle is not being updated.
Our server is now passing all of the data that we receive from the referee to the other player, which means that on paddle X at the current player's paddle in, so the two paddles contains the X to use a different broadcast, which will send the, except for the one that originally emitted that paddle move event, so that the sender doesn't needlessly get updates on their own position, which they're already aware of. So we're going to do socket for the sender.
So here, we on the paddle move, we're just emitting is the paddle move. So the broadcast emit that. So on the client, we are listening to this event. So with that on, paddle move, paddle data. The opponent paddle index is here.
Now on the client side, the game state position from our paddle data. We know our paddle index is 0, and it would be 0x from 1, which again means
Opponent paddle is 1 minus paddle index, and the paddle x is the opponent paddle index, which is equal to the paddle data dot x position, which is data that we are sending here. We're doing this inside of the mouse move.
if our paddle index is 1, go into a 1. But the game hasn't started because load game function. We only emit our ready event the first time. With the way our code is written right now, I am currently moving the client on the happening with the ball position, and a 0 into a 1. We know our paddle index, which is index.
This is quite
exactly the variable that we just updated here.
Because here we're emitting is socket.emit. We start the game here. Socket.emit paddle data like this, and the x position, which is the paddle x and the paddle index. You just only resend this data. But it's not updating. Okay, but it's not updating. It's not keep. Okay, it's not. Okay, it's not updating. It's the client. It's not updating the client. It's a paddle move and ball move. So meaning is that so paddle on. Here, something gonna make paddle data is not paddle data because it's paddle move. That's what happened. Paddle loop. So if we now restart our server, that's right. So now we are keep sync, and even the ball movement, and then we got it. Holy moly.
So we're sending the current player's paddle position. Here's a quick one for you. What happens when one of our Pong clients disconnects from the server? Well, there's
Interesting. So with this, right, we keep our client up to date. Okay, that's great. So with that, that'll be all for this video. Take care. Bye bye.